Today, we are talking about accessor and mutator methods within the classes that we write. So, if we remember back to the first lesson from this unit, we should always be giving our instance variables private access. We do not want any person, any user to have access to our private instance variables, so we mark them as private rather than public. In order to allow users to interact with these private instance variables, we need to implement public methods that will either gain access or either surface information about the variable or change the variables. These are called accessor and mutator, or getter and setter methods. And we're going to be talking about some of the nuances within each of these different types of methods today. So for accessor methods, we need to write an accessor method for any piece of data within our class that we want the user to be able to see and or work with. So if there's something within our class that the user should have access to, at least be able to see, we want to make an accessor method for that instance variable. Now, these types of methods are very, very straightforward. All we need to do is return the value being requested. Because each method can only return a single piece of data, we need a separate accessor for every instance variable we want to make accessible to the user. So as an example, let's say from our rectangle class, we want to let the user access the width instance variable. We can have our public int get width, and then we will return that width value. Of course, just like any time we are working with methods, we need to ensure that the type of data we're returning matches the declared return type. And this is the rule of methods that we've learned for a while now. Just make sure that those types match. So if I return a primitive value using an accessor, we're always going to get a copy of the initial primitive value back. We're going to get the value, but we're not going to change anywhere else if we happen to change something else. Let's look at this example to explain that very confusing statement I just made. So if I make a rectangle object, new rectangle 10, 15, that's not 15, that's just number 5. New rectangle 10, 5, width of 10, height of 5. Our width tester is just an int variable. That's going to equal rect.getWidth. So that's going to get the value 10, because that's the width that we defined here. So if I print width tester and rect.getWidth, those should both print 10 right now, because currently I haven't done anything to width tester to make it not be 10. Those are both going to give me 10. If I set width tester to equal 14, obviously width tester is going to change. And since this is a primitive value, 14 is an integer, or an int, not an integer with a capital I, this is not going to affect any variable, any value other than width tester. So if I print both width tester and rect.getWidth again, only my width tester is different. Now it's 14, where getWidth is still 10. So this is how primitives work. We've been discussing this for a while. Anytime we are working with primitives, changing one primitive variable is not going to change any other primitive variables. Now, if we return an entire object using an accessor, we can sometimes run into the problem of making aliases, where we've learned this before, but multiple variables that are referencing the same exact object's data. So if I change one of those objects, every other object with the same reference is also going to change. So if I have, if I wanted to return from a superhero class, if I wanted to return their superpower for whatever reason, you can have public power get power and then return that superpower. So if I were to do something like this example, I make a power of flight equals new power flight 5. Superhero super flooper. That's a new superhero. His name is Flooper. His power is flight. Now, if we remember back to day 1, we made sure that in our constructor, we made a new flight or a new power object so that flight and the superpower instance variable within my superhero are not going to be the same as each other. However, if I call my getPower method, if I say power test equals superflooper.getPower, then test and the superpower within superflooper are going to be aliases of each other. So if I get the power from my superflooper and I print test, I'm going to print both of those. Our power is flight, strength is 5. Power flight, strength is 5. And then if I set the strength within my test object to equal 10, and then both are going to be updated. Wow, that doesn't fit. It fit when I was making the presentation, so I don't know what happened. But now both of them are changed, which usually is not what we're going to be aiming for. So as an alternative to returning an entire object from your class, if you have an instance variable that's an object, instead of returning the whole thing, you could implement methods that will call the accessor methods from that object. So you could have a method within your superhero class called getPowerName, which is going to call the getName method for your superpower, which I think is a bit of a safer way to interact with your instance variables, because then you're not going to be worrying about making any aliases. You're passing down the chain rather than having the potential to have multiple objects with the same reference. One method that we have been working with throughout our time with objects and classes is the toString method, which is automatically called anytime we try to print out an object. Now, since this is a method that provides information about the instance variables of an object, this absolutely counts as an accessor method. So my toString method, this is for my power class. I will return a power of whatever the name of the power is with the strength of whatever the strength of that power is. So this method is providing information about my two instance variables for the power class. This is totally an accessor method. Just a little paradigm shift in your brain there. Now, mutator methods are the opposite of accessor methods, where instead of retrieving information, we are going to be changing our instance variables. So, like I said, we use them to change the value of private, instance, or static variables. And we're going to be getting more into interacting with static in future lessons in this unit. But if I have a setWidth method, I'm going to get a new width as a parameter. I'm going to say that the width instance variable for my class equals that parameter, that new width. And since we are just going to be updating a value within these methods, they usually don't need to return anything. So we will have void as their return values, with their return type, because if I'm just updating a value, nothing needs to be returned from this method. Additionally, we don't need to accept parameters for a mutator method. So if I wanted to have my mutator method where I'm getting that new width and reassigning my width value to it, that works. However, I could also make a setWidth variable, or setWidth method, excuse me, that just increases my width value by 1. It just increments it. And that is also a perfectly valid accessor, not accessor, this is a perfectly valid mutator method. Now, a major benefit of mutator methods, and one of the reasons that we use them instead of just making our instance variables private, is that they allow us to do some error checking on our inputs. So if I have my set width method and I get a new width as a parameter, I don't just have to say width equals new width, because at that point, I'm just accepting whatever the user gives me, no matter what it is. And if they give me potentially bad input, if they give me 0 or less, if they give me a negative number, a rectangle can't have a side that is 0 or less length. That doesn't make any sense. So what we can do is we can introduce some error handling into our assignment. So if our new width is greater than 0, if our width has any value at all, then we can say width equals new width. We can reassign our width to have that new width because we know it's valid. It's not going to give us an error if we try to, let's say, get the area of this rectangle. And then if our width was not greater than 0, so in the else, we can print, hey, that wasn't a valid width. So you're not allowed to do that assignment. So maybe try again. Now, similarly to accessor methods, when one of our instance variables is an object itself, we can pass our mutations down the chain through our mutator. So if I had a setter method to set the power of my superhero class, I could get a name and a strength, and then call my superpower.setName, superpower.setStrength with those two parameters. Now, I personally would recommend splitting these up as well, compartmentalizing your changes so that you're not updating your whole object all at once, but that is my personal preference. You're free to do that however you like.
Can you show that last slide one more time?
Absolutely. So here, this is if I had both updating at once, where in the next slide, I have it split apart, where I'm setting the power name and setting the power strength, but I have the same 2 lines of code, just in separate methods.
All right, thank you.
Yeah. So here I have set power name, getting the name, calling superpower.setName, and set power strength, where I'm calling superpower.setStrength. All right. Any questions on how accessors or mutators or any of that fun stuff works? That all make sense? This is a pretty logical, pretty simple lesson. All right. That is going to be our lesson for today then.